Let's study 10th standard ICSE Biology Chapter 8, the Circulatory System, Part 2, the blood circulation by heart.
Notice how both the atria pump the blood to the ventricles at the same time, and then both the ventricles pump the blood to the respective arteries at the same time. Also notice how the valves open and close in succession. And this opening and closing of the valves creates the lub-dub sound, which we hear as the heartbeat. The heart is right in the center between the two lungs and above the diaphragm. Yes, it is in the center. It's just that the left ventricle, which is the most powerful part of the human heart, is towards the left, so we feel as if the heartbeat is coming from the left of the chest. Also, the size of the heart is equal to the size of your fist. It is covered by a membranous covering, a double-walled membranous covering called pericardium. It contains the pericardial fluid, which reduces friction when the heart beats and also protects it from mechanical injuries. Now, this diagram is important. We have the left atrium and the right atrium, the left ventricle and the right ventricle. Let's understand the process of heartbeat. First, the atrial systole, that is the atria contract. So obviously that will be ventricular diastole, that is a relax. So when the atria contracts, the blood pressure increases, which opens up these two valves. This is the tricuspid valve and the bicuspid valve, because it seems to be having 3 cusps here and 2 cusps here. This ensures that the blood will be allowed to flow into the ventricles, but the backflow will be prevented subsequently. Note that at this time, the valve of the vena cava, the valve of the pulmonary vein, and the valves of the pulmonary artery and the aorta are all closed, so that the blood cannot backflow into them. Now, these valves at the base of the pulmonary artery and the aorta are like a half moon, so they're called semilunar valves. And the closing of the semilunar valves during the atrial systole produces a dub sound. And soon after this, we have the ventricular systole, which is the atrial diastole. Now at this time, the ventricles contract and the muscles of ventricles are very thick, especially the left ventricle. So blood is pumped with great pressure here. And this pressure ensures that the valves, bicuspid and tricuspid valves, are closed. Only the semilunar valves will open, pouring the blood into the respective arteries. So the left ventricle will pump the oxygenated blood to the aorta, which will take it to the whole body, and the right ventricle will carry the deoxygenated blood into the pulmonary artery, which will carry it to the lungs. And at that time, as I said, the bicuspid and tricuspid valves will close. This is also called mitral valve. And this closing produces a sound called lub. So this lub-dub sound is actually the closing of the valves, which we hear as the heartbeat. And notice that simultaneously, even these valves are opening up because the auricles had relaxed. So they could now accept blood from the vena cava and the pulmonary vein respectively. Note that pulmonary vein is the only vein which carries oxygenated blood, and that is from the lungs, and vena cava carries deoxygenated blood from the rest of the body. Yes, in the fetus also there are some exceptions where we have the artery carrying deoxygenated blood and the vein carrying oxygenated blood, but that's a part of the reproductive system chapter. So now you know how the cardiac cycle takes place and how the sounds of dub lub happens. And this entire process takes around 0.85 seconds. That is, in an adult, it happens 72 times per minute. So next time, instead of saying from the bottom of my heart, you can say from the ventricle of my heart. Now study the parts of the heart very well. This partition here is called the septum. There are some papillary muscles here, attached to which are the chordae tendineae, which keep these valves down. They hold them down. They prevent it from getting upturned. You see, when there is great pressure on them here, they should not get upturned and opened up in the opposite direction. That should be prevented. So that is prevented by these chordae tendineae, like the strings of a parachute, preventing it from getting upturned. The superior vena cava brings deoxygenated blood from the upper part of the body. We have the inferior vena cava or posterior vena cava bringing deoxygenated blood from the lower parts of the body. The aorta arches back, and then we have many arteries arising from the aorta, providing blood to various parts of the body. But one branch provides oxygenated blood to the heart itself. After all, the heart also needs blood supply. It needs nutrition and oxygen for working. Its muscles need these things. It doesn't use anything from the blood which it is pumping. It's like a cashier. A cashier handles the money for the company, but he doesn't take any money from that cash he holds. He waits for his salary. Similarly, the heart muscles will be delivered their share of oxygen by the coronary artery. And of course, a coronary vein will take away the deoxygenated blood and pour it directly into the right atrium. Now, if there is a blockage in this coronary artery because of some plaque being formed, that happens when you eat a lot of those fast food, cholesterol-filled fatty food, which you love so much. Well, if the blood supply is stopped to your heart, then that part of your heart will stop working. So initially the heart muscles will pain, which is called angina pectoris. And when the part of that heart stops working, it's called myocardial infarction, or in popular language, heart attack. Heart attack is not the same as cardiac arrest. Cardiac arrest means the entire heart stops working. So next time somebody tells you that when the person watches you, his heartbeat increases or misses a beat, there's restlessness, inability to sleep, it could be hypertension or myocardial infarction symptoms. Now remember, the time frame is that the atria, they perform their systole or contraction for 0.15 seconds. The ventricles have their systole for 0.30 seconds, and all the chambers are relaxed for 0.40 seconds. So the entire cardiac cycle lasts for 0.85 seconds normally. Now on the top right corner of the heart, we have the sinoatrial node. It has some special conducting fibers called Purkinje fibers, and this is called the natural pacemaker of the heart, which ensures a rhythmic beating of the heart. It gives the impulses for the walls of the heart to beat after regular intervals. But if this pacemaker is damaged, then the person may have to surgically get an artificial pacemaker, a small machine with a very long battery life, of course, so that the heart beats rhythmically. Now let's understand the difference between the blood vessels. The vena cava is the biggest vein and the aorta is the largest artery. The difference between them is that arteries have thick walls, whereas veins have thin walls, due to which they are lumen. That is, this cavity through which blood flows is larger, whereas arteries have a smaller lumen. And that's why the blood pressure in the artery can be great. After all, the heart pumps blood into the aorta and the artery, and the veins simply receive the blood back to the heart. So the blood pressure is going to be more in the artery, which is fine because their walls are thicker and elastic, unlike veins. We need to learn all the parts of the artery and vein, the external, middle, and the innermost layers. And we have capillaries, of course, which are the tiniest blood vessels. They don't have any muscles. It's totally an epithelial cell layer, single layer. So arteries branch into arterioles, arterioles branch into capillaries, capillaries join to form venous capillaries, and they join to form venules, and venules join to form the veins, which ultimately join the vena cava. So you need to remember this chronology. During hot weather, the capillaries to the skin, they dilate so that there is increased blood supply to the skin. That's why we appear reddish. It's very hot. This is to increase the heat loss during this summer weather, and also to increase the sweating to cool us down. This is called vasodilation. On the other hand, vasoconstriction is the constriction or contracting of the walls of the blood capillaries in our skin, which happens during cold weather, and that is why the blood supply being decreased, we appear bluish in very cold climate. This is to preserve the heat in our body and to decrease evaporation. We need to know the difference between arteries and veins. Now, arteries don't have any valves because blood flows under great pressure, but veins need to have valves so that backflow of blood doesn't happen, because usually blood flows against gravity in the veins. So here, as the blood is moving up, what if, and that too with low pressure, what if the blood starts moving in the opposite direction? That can be prevented with the help of some valves in the veins. Also, arteries are usually placed deeper inside because blood flows through them with great pressure, so they need to be deeper. There are some exceptions. For example, in our wrist, the radial artery, there is one radial artery out here. You can feel the pulse with the radial artery. that's superficial, just under the skin, and that's the danger. If it gets cut, then the blood comes out with great force, and if it's not stopped immediately, then it can lead to a huge loss of blood. It can even cause death. Veins, on the other hand, are superficial because blood flows to them with less pressure. So even if it is cut, still it will get clotted easily and quickly. Next, let's talk about something called the hepatic portal system, a very important system here. Usually, arteries deliver blood, oxygenated blood, to an organ like the kidney is provided blood with the renal artery, and the blood becomes deoxygenated, although it becomes pure because the urea is removed. This deoxygenated blood is collected by the renal vein, which joins the vena cava, which goes to the heart, and it gets oxygenated by the lungs, etc. But if you look at the mesenteric artery, which carries oxygenated blood to the gut, which is the intestine, from there, the deoxygenated blood, which has actually absorbed all the nutrients like glucose and amino acids from the intestine, it doesn't join the vena cava. It first goes to the liver. The liver will first check this blood. If it has toxins, it will try to detoxify it. It will do deamination of the excess amino acids. It will store the excess glucose as glycogen. And then the blood will be transported to the vena cava via the hepatic vein. So this vein, which starts with capillaries and again ends with capillaries, which is not the way other veins are, such a vein is called a portal vein. And we have the hepatic portal vein, which is an exception compared to all other veins in the body. And we know the reason why this is important. It's important to check the blood at the liver site before releasing it into the vena cava. Also, it's good to know the various arteries and veins in the body, the carotid arteries in the neck, which provides oxygenated blood to your head, and the jugular vein carries deoxygenated blood away from the head. So carnivores often attack the neck of animals because perhaps they had studied in their youth that the neck has carotid artery, which if cut will stop the blood supply to the head and the animal will die quickly. Look at the lion attacking a buffalo or something. They will always attack the neck. We also have the subclavian artery, which is near the clavicle. The clavicle is a bone out here, the shoulder bone. Not exactly a shoulder, a collarbone rather. We have the iliac artery providing oxygenated blood to the lower limbs, and the iliac vein carrying deoxygenated blood back from there into the vena cava. The pulse that we measure would give us the indication of the rate of the heartbeat, because after all it is the alternate expansion and elastic recoil of the walls of the artery, the radial artery, during ventricular systole. Ventricular systole is the most powerful, which we can feel by calculating the pulse. So the arteries being elastic will expand when blood flows, and it will recoil when the blood goes away. You may know people with blood pressure, because all the people have blood pressure, of course. The normal blood pressure, the systolic pressure during the ventricular systole. When I'm talking about systole, I'm focusing on ventricles here. Ventricular systole is great. It's around 100 to 140 millimeter of mercury if measured by the sphygmomanometer device. And the diastolic pressure, that is a ventricular diastolic pressure, when the ventricles relax, the pressure is just 60 to 80 millimeter of mercury. So that's a normal range. If the blood pressure is above this value here, then we say you have hypertension. Now the lymph, as I had explained earlier, is derived from the tissue fluid, and tissue fluid is derived from the blood. When the blood plasma and the WBCs leak out from the capillaries and they fill all the intercellular tissue space, it is called the tissue fluid. They don't have RBCs or platelets, but they do have WBCs, and they have absorbed substances, dissolved substances like oxygen and carbon dioxide and wastes. And this excess of tissue fluid may flow into the lymph channels, and now it is called lymph. Again, it will have WBCs but no RBCs and platelets. It's very important to give us immunity, and that is why exercising is essential, because the heart can beat and push the blood around the body, but the lymph can move only in one direction, only by the muscular contractions of the body, and the lymph helps to distribute the dissolved oxygen to the far away corners of the body where even the blood can't reach. And of course they have WBCs, so they are very important for our immunity. They also help in absorption of fats from the intestine. If you remember, the amino acids and glucose after the digestion is over is absorbed by blood at the site of the small intestine. But the fatty acids and glycerol cannot be absorbed by blood. They are absorbed by lymph through some lymph vessels called lymphatics, which are present in the intestinal villi. Lymph nodes like tonsils and other lymph nodes in the body, as you can see in the groin area, in the armpits, are very important because they try to localize the infection. So when you get an infection, you may see a swelling in the lymph nodes. That's just a protective sign. It means that a war is going on, and hopefully you will win the war. with the germs. Spleen is a lymph organ. Again, it's the size of a fist, a clenched fist. It is situated in the abdomen behind the stomach and above the left kidney. Function of spleen, it acts like a blood reservoir. So if there's an emergency, like a hemorrhage, which is internal bleeding, or carbon monoxide poisoning, it will release the stored blood, the stored RBCs for emergency. It also produces lymphocytes and destroys the worn out RBCs along with the liver. In an embryo, in fact, spleen is the one which produces RBCs because embryo does not have any bone marrow yet.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.